Welcome to another session of Teaching Math in Elementary Schools. Please be mindful of assignments that are due. Math instruction isn't work could better teacher training help. Students often get weird concepts in math, developing logical thinking routes for answering questions. What do we know about the science behind good math education, and what's preventing that knowledge from making it into the classroom for students to fall behind? But many people believe that math instruction in the U.S. is not working. Teaching students math means developing their problem-solving, thinking, and reasoning skills. We have to move students from understanding a concrete math concept to grasping abstract concepts. We're not preparing teachers well in math, according to some professors. Teachers seem to struggle with the conceptual understanding of math themselves. The focus is more on showing students or teachers how to implement curriculum rather than on growing teachers' depth of knowledge or pedagogy. Elementary math textbooks claim to be aligned with Common Core standards, but most of the time they're not. Textbooks can treat math as a series of disconnected and isolated concepts, which makes comprehending math concepts difficult and even spread math misconceptions. I have a daughter who's in 5th grade now, and the way that the textbook they are using is displaying math is heartbreaking because it doesn't give students a clearer picture of how math ideas are connected. Realities like this can force teachers to heavily modify materials so they can use them. It's an unacceptable amount of work on teachers, and they need to invest in more high-quality professional development.
And teaching strategies. I am your narrator, Frank Avella. Here, we're going to cover a number of different topics, including the development of basic skills and classroom teaching strategies. Now, we're going to begin this presentation with a broad overview of mathematics instructions. The research has shown the effectiveness of early start programs. Young students are better prepared and have improved opportunities for success when learning mathematics at an early age. Research also demonstrates the significance of the classroom teacher on the success of the child. Ineffective classroom teachers can seriously hinder a child's academic growth in mathematics. Explicit systematic instruction is considered to be one of the most effective methods of teaching mathematics. Teachers model skills, guide students on that skill, and check for understanding. Teachers should emphasize math's priority standards. Priority standards are your must-know standards needed for mastery to advance to the next grade level. On to the next topic, which is the various assessments for mathematics instruction. Assessment of student performance is absolutely necessary for instruction, just as is providing feedback. Due to the number of different skills in a given mathematics curriculum, it is essential for classroom teachers to frequently check for understanding CFU to ensure they aren't moving too fast and that students aren't falling behind. RTI, response to intervention, and intervention and referral services are necessary to identify students at most risk These are tiered interventions. Diagnostic testing is recommended early on in the year. Teachers can use diagnostic testing to unit plan and target specific areas in need for groups of students. Many schools implement systems of student tracking, which occur throughout consecutive grade levels and years on end. Standardized tests are an important measure in student tracking. In the classroom, the Criterion Reference Test, CRT, is often used to measure the degree to which a student has mastered a specific concept or skill. The next topic to be covered is instructional classroom guidelines. Now, there are certain classroom guidelines and practices that any grade mathematics teacher can benefit from using. All classroom teachers should set high expectations for their students. By having confidence and belief in your students are motivated to achieve success. Active participation is an important component of instruction. Effective teachers are able to engage their students and get them to join in the discussion. Research shows that students are more likely to participate and engage when the content is related to their personal lives and to real-world situations. Teachers should try to relate their content to the real world if applicable. Concrete instruction occurs when students are able to learn mathematics through concrete objects, manipulatives, and hands-on learning experiences. Should set in place short-term and long-term goals for their students. Goals should be, quote, smart, specific, measurable, achievable, realistic, and timely. Continuing, we move on to the next topic, which is problem solving for mathematics. Students should be taught the basic processes as well as the necessary critical thinking skills needed. For example, students may require their own personal toolkit to solve math problems, which basically means using flowcharts, drawing diagrams, checking for solutions, constructing models, etc., etc. There are also a number of specific problem-solving strategies that work best for mathematics. To that point, working backwards in word problems can help find solutions. Next is application. Just because a student understands a concept doesn't mean they can apply that concept in real-world situations. Cooperative learning and grouping strategies are also an excellent way to teach mathematical problem solving. Students get to practice their soft skills where they're able to learn and work with others. Right now, I want to take a short break and ask that you please subscribe to this channel. Also, don't forget to hit the thumbs up button and check the description for a link to the PowerPoint presentation. Moving forward, let's begin with pre-number skill and one-to-one correspondence, which is basically an understanding that each object in a group can be counted only one time. So if you hand out 3 pieces of paper, each student gets only 1 piece of paper. Each piece of paper corresponds to 1 student. Teaching with flashcards, when showing the number 3, have 3 objects on the card. Next is classification, which is essentially the ability for students to sort objects and ideas. For example, think variables for different objects. X can represent the number of hats, Y can represent the number of shirts, Z can represent the number of socks. With respect to clothes, students should be able to classify the socks and put them in a, quote, sock basket. Next is seriation. That is the ability to rank objects by degree. For example, students can rank objects based on their length. Now let's get back to it. And next we'll take a look at numeration, which relates to the process of counting. Students should be skilled at estimating numbers. For example, what is the price of a cheeseburger or a gallon of milk? Teachers can ask students to estimate how many other students are currently in the classroom. Understanding the value and properties of number 0 is also very important. Students should know that 0 means nothing. Like in this case, there is nothing in the box is empty. They should also recognize how 0 is used with respect to place value, something that comes up next. Take a look at these 3 examples. Notice the different meanings of 0. The next component of numeration is regrouping, which relates to borrowing numbers with addition and subtraction, amongst other things. For number 28, for the example of 28 plus 64, the student did not carry the 1 here. What we have here is a general misunderstanding of place values that leads to an incorrect answer. This all leads into the next topic.
When you write, your tone influences how readers respond. With Grammarly, just highlight your text and type how you want to sound.
Groupings of ones, tens, hundreds, etc. and so forth. Take the number 312 for example. Students should know that the 3 is in the hundreds place, the 1 in the tens place, and 2 in the 1 spot. 312 can be named as 3 hundreds, 1 10, and 2 ones. Another method for teaching place value is to use unit blocks, such as singles and tens. Let's say you have 16 units. Well, that can be represented as a single unit, and 1 unit of the 10 blocks piled up together into a set. And now on to the last component in basic skills, which is adding and subtracting with efficiency, computational skills. Computational skills include addition, subtraction, multiplication. Many simple arithmetic mistakes are a result of poor handwriting. Some students write very sloppy, and they wind up misreading their own written work, which leads to the wrong answer. Visual detail is another component. Students simply misread the arithmetic. 3 plus 2 is read as 8 plus 2. This happens when students rush their work. Other arithmetic mistakes happen with memory problems. Things like basic times tables must be memorized by students early on in mathematics classes. Next is calculators, which are obviously very useful with arithmetic. Still, the student must be actually taught how to use a calculator, such as its keys, functions, how it reads. The next domain of this presentation is teaching strategies. Manipulatives are physical objects that are brought into the classroom and used as teaching tools. Manipulatives are quite effective, in particular when teaching fractions. They are great for visual representation, and younger students love working with their hands. For fractions, there are fraction rods and pie charts. Playing cards are great for manipulatives. They can be used not just for probability, but for many other activities. Students do need to be taught about different suits, what an ace means, different suits like hearts and diamonds. Counters are manipulatives used in the younger grades. This helps children with numeration. In the example here, there is only one color being used. In fact, most have different colors. Lastly, playing dice, teaching one-to-one correspondence through board games. Have students count the steps they actually take after rolling the dice for the board game. The next type of teaching strategy is the use of games, and for this video, overall mathematics games makes learning fun and motivates the learner. There are a number of different classroom mathematics games, such as Math Bingo, Jeopardy, Round Robin, Buzzer Beater, and many more that you might come up with yourself. Find one game that you like and incorporate it into your instruction. Gamification is a little different than Math Bingo. Gamification is the idea that creating a competition or reward system for students based on achievement leads to increased motivation. A game-based learning, on the other hand, relates to Math Jeopardy and things like that. Now, there are many math skill learning games that are electronic, where the students must actually solve math problems while playing the video games themselves. The third strategy is peer support and peer tutoring. Peer support brings students together to learn and practice math skills. Peer-assisted learning strategies, often called PALS, has become very popular in higher education. PALS is essentially a peer tutoring program where the peer tutoring is highly structured. Peer tutors are trained to be mentors and leaders. There is also a social benefit. Socially awkward students may have a difficult time making friends. Reciprocal peer tutoring is a different form of tutoring. Here, students are usually grouped with more than 2 students. Students monitor each other and work towards academic goals. Continuing with teaching strategies, we'll explore the CRA model of mathematics teaching. A CRA stands for concrete, representational, and abstract. And it is a 3-phase model designed for mathematics intervention. Educators begin by teaching the math concept and model it with concrete objects. Students get to manipulate those objects with their hands. The next phase is representational, where the teacher transforms the concrete object into a semi-concrete representation. This level may involve creating drawings, filling in circles, adding marks to a piece of paper. The last phase is the abstract stage. The last phase is abstract, which is the most difficult for students to comprehend. This is where students must add and multiply numbers on a piece of paper, such as 14 plus 7, or 10 times 2. Now on to the last of our mathematics teaching strategies, which is the use of repetition. Repetition provides the needed practice to master a skill. Like anything in life, practice makes perfect. Practice is needed for developing math fluency. Math fluency is the ability to recall facts and answers automatically without having to think about it. When using repetition to teach mathematics, educators are advised to chunk information for their students. Chunking is an active learning strategy. Information is grouped into small and meaningful chunks, making it easier to recall. Lastly, spaced repetition, something I continually preach on this channel. Students are more likely to remember what they have learned when that information or skill is repeated in spaced intervals. Now, as we come to the end, we'll explore our last category, technology. And due to recent social distancing measures, math teachers have been forced to incorporate technology into their instruction. Both Zoom and Google Meet are great tools for incorporating live instruction, as well as using questions and answers. YouTube videos are great for reinforcing a concept. As the math curriculum grows, one way to tackle that achievement gap is to flip the classroom to mathematics YouTube videos. Jamboard and Canva are interactive whiteboards. You can erase, bring in images, share the Jamboard with others. It has many features. Kami is an excellent tool that I learned from Ms. Downey. I mostly use it to annotate text. Teachers can fill in the worksheets for their students electronically. And lastly, GeoGebra, which is great for providing graphic calculators similar to Desmos, which is also useful. GeoGebra provides open space to create triangles and much, much more. Right now, I want to say thank you for your time. Subscribe to this channel.
Okay. 2, 4, 6, 8, 10.
Third grade teacher Mona Eel is asking her student Nairobi questions to push his mathematical thinking.
Okay, so here's my question, Nairobi. How much sandwich can each child have?
When kids are thinking about their answer, that's when they're learning. When I'm giving them the answer and they're trying to remember it, that's not learning, that's just remembering.
Mona is using a method called cognitive guided instruction, which encourages students to work out math problems using their own thinking.
The fundamental strategies in being able to do this kind of work are allowing kids time to grapple and allowing kids time to think and own their understanding. It's the discovery of their own algorithms versus the direct instruction of algorithms. 4 children went to Subway. They want to share 10 sandwiches equally. You have 8 minutes to grapple.
Each lesson is comprised of the introduction of a problem, a period of time for students to grapple independently, a collective discourse about their mathematical thinking, and a process of trying to prove their ideas through drawings or models. In this video, we've highlighted 3 important strategies: the power of student discourse, the use of anchor charts to document student thinking, and questioning strategies used by Mona.
I want you to really push yourself right now, Chris, and think about how much does each person get?
So there's a lot of solutions that are out there, and we sit down together as colleagues in 3rd grade. We chart out, we kind of plan out all the solutions from the most basic to the most advanced. From there, we can think about how are we going to push or question or nudge this kid who's doing this to the next more advanced strategy.
Are there other ways that you can show one whole?
3/3.
3/3. Where did that number come from?
And that is a way that we feel like we can still be in the driver's seat while it really lets kids own their own thinking.
What are you doing now?
I'm sharing 2 parts because
I try really hard to be a neutral. Instead of telling kids if they're right or wrong, I always say, interesting.
Interesting.
While kids are working at their desk, I'm looking for examples that I can highlight for the whole class.
It's like 2, 4, 6, 8, 10.
Nairobi was doing a really sophisticated strategy where he said, I don't have to draw out each sandwich anymore. I know that 2, 4, 6, 8 is 2 sandwiches per person. I had to talk him through what he was going to do next. And I tried to do it with questions, and I tried to do it with not completely drawing out the sandwich for him.
How much sandwich can each child have? I wonder if it might help you to draw those 2 sandwiches in. How could you write that? Using numbers, maybe. Okay, how many sandwiches is that? How many sandwiches are there altogether? How do you know that? Did you use up all the sandwiches? Can you tell me what you're thinking? So what are you going to do with that last sandwich?
I can split it into 4.
Awesome.
He was doing some thinking that I thought was really important for some of the other kids to see. Okay, guys, go ahead and put that away. I need Ilani, Vashon, and Nairobi to bring their work to the rug for us. Then we move to the rug, and we sit in a circle, and kids are listening to their peers share out their strategies, and then also questioning them while I chart it up. Okay, so you did 2, 4, 6, 8, and then what, Nairobi?
Now I made a rectangle.
I chart the strategies that kids use to solve that day. Sometimes they're right, sometimes they're wrong. It's the student's job to say, that doesn't look right to me, that's wrong. And if they don't, then I am asking some more leading questions that are, okay, let's dig into this one solution. Everybody, I see quite a few unsures. I see some I disagrees. It's not an ending point, at the end of our discourse. It's just an opportunity to see where's our thinking right now. And those are archived. The next day, I'm going to say, look back at the chart from yesterday. Think about that strategy that made sense to you. Can you use that chart in the way you solved today? So all this leads to the discourse, where students are talking about their peers' strategies, and that's where the heart of the lesson is.
I want to go on Nairobi's answer. I think I can help him do the last part.
And I really try to get kids to think about the other kids' thinking.
2 holes and 2 pieces of the 4.
How did you get that?
I got that because he split them into fourths, and the N got 2 of the 4.
Jocelyn's saying that Nairobi's answer is 2 and 2/4. Now I need to know if you agree with that, and I want you to talk about that with your partner. Is that true? Do you agree with that? Yes or no? And why? Prove your math thinking. Why? Okay.
I agree because Nairobi got 2.
Kids have a lot of math thinking. If they don't realize that they have to prove it, then it's just living in their head.
Like if you draw a hole under the 2, it would be the same size. Yeah.
I think the value of doing this is that it levels the playing field for all kids. Like, all kids have access to this problem, and they have the opportunity to solve it in whatever way makes the most sense to them. So tomorrow, we're going to keep working on convincing you. And we're also going to look at Ilani's solution to see if that's the same, because she got an even different answer. So pat yourself on the back for proving your math thinking. That was hard work.
Get your free copy of my new best-selling book, Commercial Real Estate Investing for Beginners. All you have to do is click on the link below and a copy will be sent to you instantly. Hi, I'm Peter Harris. I'm the author of this book. I'm also the author of one of the most successful
Primary 1, most kids are so nervous about learning about maths. After they go through all these games, they're much more relaxed and they learn more and they are excited to know more about maths. Now they have more opportunity to get to hands-on games and learn through games for maths, these sort of things. But our time doesn't have these sort of things.
Manipulative such as fraction list, multiplication and division card. It makes it more fun and math lessons will be much less boring.
Yeah, we play a lot of games and it's even better than last year's.
P1 he doesn't like maths, but now he's very excited and he loves maths also and he's learning more.
I can count money faster. If I'm very hungry, I can just go and give the auntie the money and get the food free.
For all these activities that we are doing in the school, we felt that the children are better engaged, and because of their better engagement, we felt that they have developed more positive attitudes towards their learning. So one of the example would be we teach mathematics through songs. The other way is to use a storybook to teach problem sums in the classrooms. The teacher used a wide range of pedagogies in the class. One of the key pedagogy is also the activity-based lessons in the classrooms. So pupils are engaged in learning by doing activities. The other programs that we have is to have maths games in the school. There are 2 types of games that they play. One is the maths stations that they have every Wednesday. The other will be the Maths Games Day that we organize for the children. We basically want to inject fun in learning for the children. So PE elements such as running, hopping are actually incorporated in our maths games, where we also design the games such that it is related to their classroom learning. What is important is how the children are learning and how they are being engaged in the classroom so that they become better learners in mathematics.
To learn about this amazing differentiation and intervention tool for kindergarten through 5th grade reading and math teachers. Oh, I'm so excited today. We are talking with Dr. Carol Tomlinson, Chair of Education Leadership, Foundation and Policy at the University of Virginia. And she's also author of Everybody's Classroom, Differentiating for the Shared and Unique Needs of Diverse Students. And Carol, today we are going to talk about differentiating instruction in the math classroom, and we're focusing on elementary, kindergarten. Can you actually differentiate instruction for math for younger students?
I think you have to, and I think that's probably the game plan all the way through school. I think there are things that all of the kids need to do together in math, but I think any teacher who's been in the classroom 15 minutes knows that just because we thought kids could learn something in 2 days doesn't mean they all did, and some of them already knew it, and some of them really are going to need considerably more time than that. So I think part of the plan is to think about shared experiences that kids can have, for example, with learning numbers or learning to count simple things, and make sure that those really cause kids to think and to try to express themselves and to show themselves in different ways. Here's a way I think of it. Here's something I can do. And then to have some time that's set aside consistently so the students in that class can take their own next step.
So you're saying spend time having shared experiences with groups where students are doing things together so they're actually part of that differentiating process.
Yes, I talk about this often in terms of highways and exit ramps. The highway is the time all the kids should be together, thinking about numbers or a little higher up, trying to figure out what multiplication has to do with addition or what that might mean if you're multiplying popcorn or whatever it is you're doing. And all the kids need to be in math conversations with the whole group, or turn and talk with 2 people but still in the whole group. And they need to be part of seeing themselves be mathematical thinkers. It's really important for kids to see themselves as part of the whole class. We're a team of learners, and I'm part of that team. And all kids need to see interesting demonstrations by the teacher about whatever they're talking about. They need to share their answers and explain how they got there. They need to try out things with a partner. And so the whole class aspect of math instruction and everything else, I think, is critically important. We are an us, and we need to be an us a lot of the time. But then there are times consistently where some kids need to spend a little bit more time on something. Some go back and patch up things or don't have the prerequisite skills they need. And some kids learn in different ways and would do much better if they could use a different mode of learning. And some kids are ready to move ahead. So the highway needs to have periodic exit ramps, and by predictable and frequent, not once every 2 weeks, part of every day, so that kids can work on things they're interested in or things that take them to their next step, or try out new ideas with peers. And even in those exit ramps, I think it's important for kids to collaborate so that they feel a part of a group. Important from my perspective to say that those exit ramps groups should not be bluebirds, buzzards, and wombats, so that every time they get together they sit in the same place, and the kids that are having trouble are always together and the kids that are flying high are always together. That's not helpful either. They need to have a very flexible grouping as well.
So this is very real to me. My mom was a teacher, and even though I went to Georgia Tech, took a lot of calculus, the hardest thing I ever really learned was actually addition. I remember first grade didn't make sense to me, and Mom sat down at the table and we added apples, and sometimes we added M&Ms, and I just remember how she worked with me one-on-one. Math didn't make sense to me, but then when the light bulb went on, it changed my life. So just because these basic concepts are difficult for students doesn't really say anything about their intelligence level, I would hope.
And that's one reason that we don't want to have bluebirds, buzzards, and wombats, because that does become predictive. Kids with less opportunity often end up in the buzzards, And everybody begins to think of them as buzzards, and they begin to think of themselves that way. And we have every reason to believe that every kid has much more capacity than we can see. And we need to, they're smart, not plug them into a slot that's going to become a stereotype.
So fill in the blank for me, Carol. As teachers differentiate math instruction and the elementary grades, the biggest mistake they could make is blank.
I think teaching it as an algorithm, teaching it as this is what we're doing, this is how you do it, now do it, versus having conversations about how that makes sense to you, why you do something, and what other ways you can do it. And look how cool it is that we can get the same answer 4 or 5 different ways, and everybody can explain it, and we learn more that way. I think part of the reason you discussed your floundering in math, my floundering happened because at a bad juncture for me. I had a teacher who had no patience for anybody that couldn't see her do something on the board and reproduce it. And it made no sense to me, and I was terrified. And so that sense, you can think your way through it, and he can think his way through it a different way than you. One of the big ideas of math that I really love is there's an infinite number of ways to get the same answer. And I think we need to show kids that in the classroom.
Wow. Some teachers feel, obviously, these days, a lot of teachers feel a lot of stress, and they have a lot to quote cover. Oh, I know you probably cringe at that word, like a lot of us teachers do. What's your advice to the teacher who just feels like they have so much to quote cover that they feel like they don't have the time to differentiate?
Well, I certainly understand why teachers feel that. The pressure on them is immense. But not only do we not have any evidence that when the teacher covers something, all the students learn it, or even that most of them learn it, we understand now that really is teaching in a way that's totally unbrain friendly. Howard Gardner long ago said the enemy of understanding is coverage. And David Sousa, who works on the brain, talks about the fact that coverage races are not brain friendly. And if we're thinking that the most important thing is that we cover something, and we have forgotten that the aim is that the students learn, then that's where we need to start rethinking things. Our goal, though, I think is twofold: to help students learn as much as they can, but also to dignify them as thinkers and as human beings, and to excite them about the world around them. That's a good reason to teach. Covering stuff for a test is not. And I think anytime we start feeling a huge amount of pressure, and we end up hearing ourselves say or think something like, I can't teach kids so they can learn because I have to cover this myself. Listen to that and think we regroup. Truth is that teachers are much happier and much more creative when they're teaching kids for meaning and when they can do it in creative ways and help kids be creative. And we also, this is hard for us to trust, but we have good evidence that when teachers teach students for meaning, they do better on the tests than when we teach them algorithms and cover things. So I think there's powerful evidence for that, but habits are powerful too.
So describe for me, Carol, a classroom or a teacher that you may have met recently. You don't have to share a name, but just describe what you saw happening in that classroom that got you really excited and you felt like that teacher understood the research and the things you espouse that need to happen for differentiated instruction in math.
I can think of two. One is a 4th grade class. I think the other one is young children. So I'll start with the little guys, and then you can decide if we have time for another example. But this was a class in kindergarten where kids were learning numbers. And so they were learning to count from 1 to 3 and 1 to 5 and on up. And the teacher, of course, they were counting everything. They'd count the days in the week that were left, the days in the week that were gone, how many people were wearing red shirts, everything got counted all day. But at a math center, she assigned students to go at various points in the day, and all of them were doing work to determine something about how many students were in their class. And what she did at the center, I think, is probably not terribly remarkable, but what she did was to give them all a task to do that was a little ahead of where they were functioning comfortably. The coolest thing about it was that after the time at the center, she met with the kids. And her conversations with them were really wonderful. So one group had to determine how many students were in their class that day, how many people are here. And those little guys were adorable to watch. They're walking around counting people who are moving at the same time. They're moving, ill-fated, but that was not a surprise. And then you'd see them counting as they knew to count 1, 2, 3, 7, 9, 11. And so the numbers were just all over the place. The conversation she had with them was wonderful. She went through each of the kids. Tell us how many people you thought were here today. How did you get that number? Do you think more people are here today than Jack does, or does Jack think there are more people than you? Oh, did you all get the same answer? No. Should we all get the same answer? Yeah. But then some kid would say, not if somebody left to go to the office. And then she ended up by saying, since you didn't get the same answer, do you think it would be worth doing this again tomorrow and trying again and see how we are thinking about it? They thought that was a great idea. And the conversation really positioned them as mathematical thinkers. She did the same thing with the second group, pretty much the same questions. That group was supposed to figure out how many kids were there and how many kids were absent. And of course, it's much harder to count something that's not there. They talked about that. They talked about greater than, less than, how they had gotten their answer. And she did the same thing again with them. And she also, after the how did you get your answer, I've forgotten what the other question was, but it had to do really with their next step in reasoning. And then a third group had to count how many boys were there, how many boys were absent, how many girls were there, and how many girls were absent. And the one question she asked them that was different than the others was, explain to us how you know you're right. The other kids, investigation with numbers, thinking about numbers, finding different ways to do things by listening to each other. But this group, even at that age, was ready to say, I'm right because I know this and explain it. It was a wonderful way to have all the kids together for the lead-in, different tasks for them to do at a center, and then conversations that accepted where they were and pushed them on a little bit further. And of course, that's a cycle that they'll keep going through. But that, I think, is an example of a classroom where all of the kids are sharing good and exciting and interesting beginning instruction and asked to do work that pushes them on a bit, and then are talked with as though they're really mathematical thinkers, because that's what they're trying to do.
I love the part of the conversation, because I think that truly great conversations are very much a part of excellent classrooms, and it's something that AI and algorithms and robotics are never going to be able to do, is to have those meaningful conversations that truly push kids. I love that. So let's talk about your second example, because we want to have two.
This is a teacher, I really can't remember the grade level, 4th grade maybe, but this is a Teaching Channel video. And this teacher is talking about how interested her students have become in math as a result of the kind of thinking they're doing. And she seems to be reflecting on a time when it was more algorithmic, formula-like. And so she's having a discussion with, I've forgotten exactly what the topic is, but she'll ask the kids, somebody to volunteer to do something, and they come up and do a demonstration. And then before that, she'll always say to the kids, turn to somebody and talk about what you're thinking and challenge each other's thinking. Does your thinking agree? Is your thinking helping each other? And after they've done that, then they finally get to the place where she'll say, okay, let's do a true-false problem. And this is not exactly what they were doing, not the same problem, but the same understandings. And so the kids determine whether they think the answer that she gave to this problem is correct or not, true or false. And she says they love the true-false thing because they love to be able to defend stuff. And she's watching the kids, and they keep doing the turn and talk, and then this little gal explains why another student was wrong. And her answer is adorable. She's using the idea of having M&Ms, for example, that the student's going to divide, and she gives this many to this kid, and this many to this kid, and this many to this kid. And in the end, this other little girl, that can't really be right, because after she's gone to the first two girls, she's already given them away. And so there isn't anything to give to the third one. And the other kids are hearing that kind of reasoning. And she says to one little boy, so what did you think about what she said? How did that make you think? And clearly he wasn't really tuned in and didn't listen. And one thing I love about it is when he pauses and it's obvious that he didn't hear what she said, that doesn't bother the teacher. She says, okay, what she says was this and this. How do you feel about that? And he thinks about it for a minute. And he said, she's beginning to make me think I was wrong. So she caused you to rethink and to understand more deeply? Yes, ma'am, I think she did. And so it's this merged conversation. But when that video was posted, and then people who watch it can post a comment. The first one there, not surprisingly, was, well, surely you don't think all the kids understand this after that lesson. And her response back to it was, oh no, this was just the whole class lesson. Meaning again that they're going to be doing things that help them go down that pathway to understanding with what comes after this.
Carol, thank you for coming on the show. You've really helped us understand differentiating instruction with the elementary classroom. This was a fantastic conversation. Thank you, eSpark, for sponsoring today's episode. eSpark is a differentiation.
Please remember that there's several epic books with math themes. Here are just a few that you can use with students in instruction. Okay, this first book is called 3D Shapes. Remember, you can add it to your favorites. You can also assign it to students. You can do it as an introduction in your lesson, or even as you use this at the end of the lesson to help summarize your lesson and the main point. But I would use this as a read aloud. It also has great activities you can do with students at the bottom. And it also highlights vocabulary and keywords and gives a glossary for students. You can also play a quiz game. And here you see there are also many other books that you can use in the. They also have a book on polygons. So this is a great way for your students to read about the various math topics that you're covering in your class. Either use it as a read aloud, students can read this with a partner, they can also read it in a group. It can also be part of your guided reading lesson or a guided math lesson. This is a good way to teach about sequence. What is first, what is second, what is third, and what is last. This is another book on geometry. Another book about graphing. And Epic also has videos, books that can be read aloud to students, and books that students can read for themselves. Last book, Play with Shapes. And you can take your students on a scavenger hunt with shapes around the school, around the playground, and in the community. Students can also do a scavenger hunt in their homes as well. So there are various topics in math on Epic that you can use with your students.
Play with Shapes by Joyce Markovics, Rourke Educational Media, copyright 2013. Grab a shovel and pail. Let's explore solid shapes at the seashore. Did you know that everything has a shape or form? Trace around the starfish with your finger. The outline of the starfish is its shape. There are many different shapes at the shore. Take a look. What shapes do you see? Here comes a beach ball. What solid shape is it? The beach ball is a sphere. A sphere is round all over. Sphere. What else do you know that is round like a sphere? What shape is this piece of ice? The ice has a cube shape. A cube has 6 sides. Each side is the same length. Cube. What are some other solid shapes at the beach? Let's find out by playing with sand. What solid shape is the top of the sandcastle? The top of the sandcastle is a cone. Cone. A cone has a round bottom and a point at the top. Cone. Below the cone shape is a cylinder. Cylinder. A cylinder is shaped like a tube. Cylinder. See the shape of the sand pile? The sand has a pyramid shape. A pyramid has a square bottom and a point at the top. Pyramid. Let's dig in the sand for seashells. What can you find? Point out all the shapes and solids you see at the seashore. Shapes and solids are up, down, and all around.
All About Math Symbols. Written by Nancy Kelly Allen. Rourke Educational Media. Copyright 2014. We use signs every day. A math sign is called a symbol. Symbols stand for things that can be counted or measured. A number is a symbol that tells an amount. How many can you count? 2, 3, 5. The plus symbol means add. Add the number of robots. 2 plus 2 equals 4 plus 2 equals 4 plus 5 equals. The minus symbol means subtract or take away. How many cookies are left? 5 minus 1 equals 8 minus 2 equals 6 minus 3 equals. The equal symbol means the same as. Do the trucks equal the same number? 2 equals 2. 5 equals 5. 3 equals 3. The degree symbol measures temperature. Which is hotter, the ice cream or the hot chocolate? 20 degrees Fahrenheit, 200 degrees Fahrenheit. Which is cooler, the pizza or the soup? 90 degrees Fahrenheit, 85 degrees Fahrenheit. The dollar symbol and the cents symbol measure money. The dollar symbol measures $1 and more. The cents symbol measures less than $1. Which is more? $3 or 30 cents? $5 or 75 cents? Which is less? $1.50 or 50 cents? $2.25 or 25 cents? The greater than symbol shows that one number is bigger than another. The greater than symbol is like a hungry alligator. The open mouth faces the bigger number. Which number is greater? 6 is greater than 3. 5 is less than 7. 8 is less than 9. The less than symbol shows that one number is smaller than another. Which number is less? 2 is less than 5. 1 is less than 4. 5 is greater than 3. Math symbols help us count and measure. Can you find the correct symbol? 7 plus or minus 1 equals 6. 3 plus or minus 2 equals 5. 1 plus 3 is less than, is equal to, is greater than 4. 5 is less than or is greater than 2. 2 is less than or greater than 3.
Play with Counting by Barbara Webb. Work Educational Media. Copyright 2013. How many are there? 1, 2, 3. 3 dogs in the field playing with me. You counted 3 dogs total. 1, 2, 3. So far, so good. Are there any more dogs in the field? Keep counting now. 1, 2, 3, 4, 5, 6, 7. 7 dogs all together. 1, 2, 3, 4, 5, 6, 7. It's doggy heaven. How about now? Did the number change? They are all mixed up. 1, 2, 3, 4, 5, 6, 7. But the total stays the same. 7. 1 dog goes home. His dinner is ready. Did our total change now, or did it stay the same? 1, 2, 3, 4, 5, 6. With 1 dog gone, now we have less. 1, 2, 3, 4, 5, 6. So this is the rule when you want to know how many. 1, 2, 3, 4, 5, 6, 7. The number you can count is the total amount. How many flowers? How many fish?
Remember, there are different types of math manipulatives you can use in your classroom, including tiles, counters, color counters, cubes, counting sticks, counting bears, which was a favorite of mine, snap cubes, attribute blocks, unifix cubes, counting chips, color cubes, and square tiles. There's the more manipulative dice, number lines, numbers on sponges or blocks.
Hi, this is teacher Nika, and today we're going to be learning something new. Hi boys and girls, how are you doing? I hope everyone had a great night's rest. Are you ready to work and to learn something new today? Awesome! Before we get started, get those books and pencils, write both of your names, the name of the day, the name of the month, and then we're going to get started. To give you a teaser, we are going to be looking at length. So get started and come right back. Welcome back. Completed writing your names, the name of the day, and the name of the month correctly? I hope so, because I'll come by and check those books, all right? Now, as I mentioned before, we are going to be looking at lengths. Look on the screen. You'll see the words long, short, and then tall, short. Do they mean the same thing? Long and tall? Many of my students would ask me this. Long and tall, it's the same. But actually, it's not the same. I'm going to tell you what's the difference. But let's look back at these words. Long, short, tall, short. When we're talking about long, long is generally used when we are measuring horizontally. And the word tall is used for vertical measurements. Look at the pictures on the screen. You'll see two pencils. One is long and one is short. They are horizontal. See that? All right. Then, when we're talking about tall, here we have two men. One is taller than the other. So one is tall and one is short. This is vertical. So the pencils are horizontal. The men are vertical. So that's the difference when we're using long versus tall. Long is used for horizontal measurements, and tall is used for vertical measurements. So there, you learned something new today. Let's look on the screen and answer a few questions. You can see some pictures here. Now I want you to take your time. We're going to look at the pictures and we're going to identify which one is correct based on the question that I'm going to ask you. First question, let's look at the two snakes. Which one is longer? Which one is longer? And if you notice, they are horizontal. Which one is longer? The first one or the second one? Which one is longer? If we look carefully, we can see the first one is longer. So if you have that answer, that's correct. The first snake is longer. Let's look at another one. Listen to the question. Which one is shorter? Now we have two alligators. Look at them carefully. Which one is shorter? The first one or the second one? The second one? I don't think the second one is shorter. The first one is shorter. If you had first, or if you said number one, that's correct. The first one is shorter. Let's try another. We have a dog and we have a rabbit. The question is, which one has shorter ears? Which one has shorter ears? The dog or the rabbit? The dog has shorter ears. The rabbit's ears, they're long and pointed up in the air, but the dog has very short ears. So the answer would be the dog has shorter ears. Let's look at another. I have two trees here, and the question is, which is taller? Which is taller? So look at these trees and tell me which one is taller. The first one or the second one? That's right. The first tree is taller. Let's look at the ladders. Which ladder is shorter? Which ladder is shorter? Is it the first ladder or the second ladder? Which one is shorter? If you take your time, you are going to see it. It's very easy. The first ladder is shorter. Nice. Let's look at the glass and the cup. Which one is shorter? The glass or the cup? Look at them carefully. Which one is shorter? According to my eyes, I can see that the cup is shorter. The glass is tall. The cup is short. See that? All right. Let's look at the refrigerator and the freezer. Which one do you think is taller? Which one do you think is taller? If we look carefully, the refrigerator is very tall. So that one would be taller. Were you able to answer these correctly? So let's review. You can see I drew circles around the tall tree, the short ladder, the short cup, and the tall refrigerator. Easy. Now I have some pictures here again. And we are only going to select the pictures that depicts tall at the top and the ones for short at the bottom. So you can take your time, draw these pictures inside of your book, and then you can circle them. So it's your turn to do it. So you'll draw the two boys, then you'll draw the dog and the giraffe, and you'll circle which boy and which animal is tall. Not short, tall. After that, you're going to draw the two flowers and the two ladders, and you're going to circle the one that is short. Okay? So for the flower and the ladder, only the short one, you are drawing a circle around it. And for tall, you are drawing a circle around the boy or the animal that is tall. So take your time, do that, and then we're going to conclude today's lesson. For me is to write the words tall, T-A-L-L, and the word short, S-H-O-R-T. All right? And then you'll practice to spell these words. Tall, short. You can also practice to spell the word long as well. L-O-N-G, long. Do you remember the differences? I hope you do. We use tall when we are measuring vertically. And we use long when we're measuring horizontally. All right? Awesome. So those pictures that you drew, you can go ahead and grab those crayons and color the pictures that you drew. And when you're finished, you can show it to mom and dad so that they can see those beautiful drawings. And also, they can check for what I asked you to do, which was to circle the tall boy or the tall animal. Then next, you have to circle the short flower and the short ladder. If you have those correct, then they can go ahead and give you that big gold star or maybe some ice cream. You never know. So take your time, complete your work. Until we meet again, stay safe and remember to read a book, even if it's just one book per day.